All right, guys, welcome back. We are on part 2. This is more simplifying radical expressions. So a couple of things that we need to talk about. This will be a really quick lesson, but let's go ahead and talk about it. So a radical expression is simplified if the following statements are true. So the radicand, so let's remember that our radicand is our symbol, right? So if the radicand has no perfect square factors other than 1, right? Because if there's a perfect square factor in there, we need to take that out, simplify it. The radicand contains no fractions, and no radicals appear in the denominator of a fraction. Okay, so these are some examples of simplified. 3 square roots of 5, so this 5 cannot be simplified. This is the same thing. And then the square root of 2 over 4. Okay, so as long as the actual square root symbol is not the whole fraction, like that, then this is correct, okay? But see how this one has it over both, not simplified. And then the square root of 12 can be simplified. And then the same thing here, 5 over square roots of 7. So no radicals appear in the denominator. That's what's happening here. All right, no fractions, and then no perfect square factors other than 1. So 12 can be simplified. All right, so let's first talk about multiplying radical expressions. So the multiplication property of square roots tells us that the square root of AB is equal to the square root of A times the square root of B. Okay, so if that's the case, then the square root of A times the square root of B equals the square root of AB. Okay, so let's look at example 1. What is the simplified form of 2 square roots of 7t times 3 times the square root of 14t squared? All right, so the first thing that we need to do is multiply the whole numbers and then use our multiplication property of the square roots. So we can multiply what's on the outside. So 3 times 2 gives us 6. And then we're just going to include 7t and 14t squared underneath our radicand together. Then we can multiply those together. So 7 times 14 gives us 98. T times t squared gives us t to the third power. Remember, with exponents, when you multiply, you just add the exponent. Okay, so then we need to simplify under the radical symbol. All right, so 98t cubed can be rewritten as 49t squared, right, because that was the 7t squared, and it's a perfect square factor of 98t cubed. Okay, so we're trying to pull out the perfect squares so that we can simplify this. So 49 is a factor of 98, and we can make it a perfect square, right? So then we're going to leave that 2t. So we're kind of just factoring this out in a way. So our 6 comes down every time, and we have the square root of 49t squared. And the reason that we've separated this is because we're going to be able to simplify this 49t squared. Okay, so times the square root of 2t. So the square root of 49 is 7. The square root of t squared is t. And then we're going to leave the 2t underneath the radicand. So then we will multiply what's on the outside. 6 times 7 gives us 42. Bring down our t. So 42t, the square root of 2t. That is your simplified final version. All right, so let's look at these. We have 3 square roots of 6 times the square root of 18. All right, so first we start with the outside. There's nothing outside of the square root of 18, so we know we're going to bring that 3 down. And then we can go ahead and multiply 6 times 18 to give us 108. All right, so then we need to factor out 108, where one of them is a perfect square. So you can take a minute to figure this out, but we can multiply 36 times 3, and that 36 is a perfect square. So 3 times the square root of 36 times 3. Okay, so now we know that the square root of 36 is 6, so we can pull that out. And there, 3 is not a perfect square, so we're going to leave that inside. Then we can multiply the outside. So 3 times 6 gives us 18, square roots of 3. All right. Square root of 2x times the square root of 9x cubed. Okay, so 2 times 9 is going to give us 18. And x times x cubed is going to give us x to the 4th power. All right, now once again, we want to simplify this into such a way that we can find a perfect square. So we can leave the 4, and we need to break down this 18. So we can do 9 times 2, that's a perfect square. So 9 times 2x to the 4th power, we'll leave that way. Okay, so 9 is a perfect square, and then x to the 4th power is also a perfect square. So the square root of 9 is 3. The square root of x to the 4th power is x squared. And then we're left with that 2. All right, same thing for C. So we have 7 on the outside, so that 7's going to stay. 5 times 20 gives us 100. And x times x to the 5th power gives us x to the 6th power. All right, now this one actually doesn't have to be simplified. 100 is a perfect square, and so is 6. So we've got 7. Square root of 100 is 10. And the square root of x to the 6th power is going to be x cubed. So then we'll multiply 7 times 10, and we get 70x cubed. All right, now we're going to be talking about the division property of square roots. Okay, so the square root of a over b is the same thing as the square root of a divided by the square root of b. And once again, if that's the case, it's going to be the same vice versa. So the square root of a divided by the square root of b equals the square root of a over b. Okay, and you can look at what I did with example 2 here on a. So 64 over 49 is broken down with its own radicand in each the numerator and the denominator. Okay, so we want to get rid of these. We can't leave a radical in the denominator of a fraction. Okay, so luckily for us, both of these are perfect squares. So the square root of 64 is 8, and the square root of 49 is 7. So this is your final answer. All right, let's look at B. So the square root of 8x cubed over 50x. All right, so the first thing that they did was separate these into 2 parts, and they kind of already went ahead and factored them out, right? So instead of saying 8x cubed over the square root of 50x, they went ahead and broke that down. So we know that 8x cubed, we want to break it down where one of these is at least one of these is a perfect square, right? So we can multiply 2x times 4x squared. All right, and then same thing for the bottom, 50x, we want at least one perfect square, so we'll do the square root of 2x times 25. Right, so 2x is not a perfect square, but 4x squared is. So the square root of 4 is 2. The square root of x squared is x. And then we're left with that 2x in the radicand. And then on the bottom, same thing, 2x is not a perfect square, but 25 is. So the square root of 25 is 5. All right, and what we can do with this one, we can't have a radical in the denominator, but the square root of 2x over the square root of 2x is going to cancel each other out. So then we're left with just 2x over 5. All right, so the square root of 144 over 9. So let's break that up into 2 separate parts. Square root of 144 over the square root of 9. Now the square root of 144 is a perfect square, so that is 12, and the square root of 9 is 3. So that one was pretty easy, and then this can also continue to be simplified. So 12 divided by 3 gives us 4. So your answer is 4. All right, same thing for D. We have the square root of 36x over 4x cubed. All right, so we can simplify this actual fraction, right? 36 is divisible by 4. So if you're not sure what to do, you can always start by seeing if your fractions will be divisible. So that gives us the square root of 9. And then it's been a minute since we've done division with exponents. So if you have 1x on the top and 3x on the bottom, we're going to be left with -2. Okay, if it's on the bottom, it's going to be x to the negative 2 exponent, okay? Now we can break that down as the square root of 9 over the square root of x squared. And the reason that we moved this to the bottom is because we have to get rid of this negative. So to get rid of this negative exponent, we have to move it to the denominator. Right? So the square root of 9 is 3, and the square root of x squared is x. All right, and then the last one like this, we have the square root of 25x cubed divided by y squared. So let's go ahead and break that up. All right, so we need to figure out a way to pull out perfect squares from this. So 25 is a perfect square, and then x squared is a perfect square. So we need to pull out one of those x's so that we can simplify as much as possible. So that would be 25x squared times x.
Second lunch, orange dine-in.
And then we'll leave y squared on the bottom. And now we can simplify that perfect square. So we can pull out the perfect square of 25 and x squared. It's going to be 5x. That leaves us with x. And then the square root of y squared is y. All right, and then the last part of this lesson is simplifying fractions with radicals in the denominator. Okay, so the process for this is to simplify the denominator if possible. And then the second step is to multiply the numerator and denominator by the same radical. Okay, so for example, we have the square root of 3 over the square root of 7. Now, neither one of these are perfect squares, but we have to get rid of this radical in the denominator in order for it to be completely simplified. So what we're going to do is multiply the numerator and the denominator by the same radical, okay? So we're going to multiply both of these by the square root of 7. So 3 times 7 gives us the square root of 21. 7 times 7 gives us the square root of 49, right? And now that we have, the reason we do that is 7 times 7 is obviously going to be a perfect square, right? It's going to be 7. So the square root of 49 is 7 because that's what we multiplied by each other in order to get that number. So our answer here is square root of 21 over 7. All right, same thing here. Well, actually, let's go to B. So we have the square root of 7 over the square root of 8n. Okay, so notice that the first thing they did before they multiplied by anything else was pull out what could already be pulled out, right? So the square root of 7. And then the square root of 8n. So they pulled out the square root of 4 times 2n. And they just skipped that step when they're showing you. So we know that the square root of 4 is 2. So we were left with 2 and then 2 in the square root of 2n. Okay, so that's how we got to this part. But now we want to get rid of this radical in the denominator. So we're going to multiply the whole thing by 2n, the square root of 2n. So 7 times 2n gives us the square root of 14n. And then we're going to keep that 2 on the outside of the denominator, and 2n times 2n gives us 4n squared. Right, so the square root of 14n can't be simplified. It's going to stay that way. But we can take out a 2 and an n, right? So the square root of 4n squared is 2n. We multiply that by 2, so we get 4n. All right, now let's actually put some of this to work. So the square root of 2 over the square root of 3, right? We're trying to get rid of the denominator, so we're going to multiply both by the square root of 3. So the square root of 3 times the square root of 3, we know is going to give us a perfect square of 3. Right? We know 3 times 3 is 9. The square root of 9 is 3. So this is your final answer. All right. Same thing here. We're trying to get rid of that denominator, so we're going to multiply the entire top and bottom by the square root of 18x. Okay, so 5 times 18 gives us 90, so the square root of 90x. And then the square root of 18x times the square root of 18x is going to give us a perfect square of 18x. Okay, but this 90x can still continue to be simplified, so we can actually pull a 9 out of there, which is a perfect square. So 9 times 10x over 18x, right? The square root of 9 is 3. 3 square root of 10x over 18x. And then this 3 over 18 can simplify, right? So 3 can go into 18 6 times. So we can get rid of this 3 if we divide it into that 18. So 18 divided by 3 is going to give us 6. So we're going to be left with the square root of 10x over 6x. The biggest thing here is just to make sure you are doing it as thoroughly as possible. And even if you find, different methods to get there, just keep going until it is completely simplified, until there's nothing else that can be done. All right, so notice here we have the square root of 7x over 3, so we need to first separate that. Okay, so in order to get rid of that square root of 3 on the bottom, we're going to multiply by the square root of 3. So 7 times 3 gives us 21, so the square root of 21x. The square root of 3 times the square root of 3 gives us 9, which we know is going to be a perfect square of 3. And that is actually as far as we can go on that one. All right, so go ahead and start working on your practice. We are almost completely done with lessons this year. And as always, if you have any questions, reach out to your teacher and let them know. Thanks, guys.